Hey everybody, this is Larry. This is me doing the weekly premium problem. 1644, lowest common ancestor of a binary tree 2. Hit the like button, hit the subscribe button, drop me on Discord. Let me know what you think about this problem. This is, yeah, let's take a look. I haven't done this one yet, but it sounds okay. Let's see. Okay, so we know what LCA is. I assume they mean none, but okay, fine. Okay, so why is this 2? Okay, so all the values are unique. You have to find, are we given the P or the Q? Or? Can you find LCA traversing the tree without checking node existence? Yeah, I mean, I think so. Basically, so there are two ways you can do it. The first way I was going to do it is just traversing the tree, and then what was I going to say? Yeah, traversing the tree, and then calculate the parent, and then just like almost like walk the path up, right? That's one way to do it. The other way to do it is to think about this as a binary tree, because it's a binary tree. The lowest common ancestor is the ancestor in which they branch off, right? Meaning if one of the node is to the left and the other node is to the right, then, or the other way around, doesn't matter, then that's your LCA. So that's basically the idea. And we can kind of figure this out. Yeah, so found is equal to none, and then here we can just do a regular traversal. Yeah, and then we have this node, right? And then maybe just something like if node is none, we return 0. Otherwise, if node is equal to P, or maybe node dot value is equal to P, right? Something like this, or P dot value rather. Then count is equal to 1. I mean, this can only really be 1, but nonetheless, right? It's actually a little bit awkward now that I think about it, but maybe this isn't quite that good, but I don't know. Right, so basically you have left is equal to, and we'll go over y in a second, right? Right is equal to traverse node dot right. So basically the idea is, okay, so if left is equal to 1 and right is equal to 1, then found is equal to this current node, right? So, I mean, yeah. Otherwise, there's the other case, right? Which is if left is equal to 1 and count is equal to 1. Yeah, right? So, okay, maybe another way of writing this is actually if count is equal to 1 and left plus right is equal to 1, right? What this is saying is that the LCA is it's the one of the nodes because the other node is the children, right? So then now found is equal to node, right? Otherwise, we return left plus right plus count. This is very standard, like counting the number of leaves or nodes or something or whatever found in this case, right? So yeah, so we traverse the root and then we return found, and that should be good. Oh, do we? That's a little bit awkward. I think we just have to kind of keep it consistent outside, that's all. Yeah, and this is very standard. The way that I structure is very standard recursion, tree recursion, traversal, depth first search if you want to call it that. So it's going to have the same linear time, linear space. You have to look at every node. I mean, you could get lucky with the inputs, but for all purposes, you have to look at each node. So it's going to be O of n time. And in terms of space, you allocate space on the stack. So it's going to be O of h space, where h is the height of the tree, or maybe just O of n, depending on how you want to say it. Because height of the tree can be n. So, okay. I think that's it. That's all I have for this one. It's the follow-up. It's actually a little bit of a hint because I actually forgot about it, to kind of do it this way until I saw the follow-up. I was going to do the lazy traversal up one, but I mean, I don't know. It's just one more pass, and they're both linear time, linear space. So I'm not going to go over memory locality optimization, but oh well. That's all I have for this one. Let me know what you think, and yeah, stay good, stay healthy, to good mental health. I'll see you next week and take care. Bye bye.